Hi everyone. We're starting calculus today. This is our introduction lesson. Our learning goals are to learn to find the slope of the tangent to a curve at a specific point using the underlying idea of calculus. So we're going to kind of look over how Newton came up with it. And then the next lesson we'll learn kind of how to generalize it into a formula. But today we're going to actually go through the process or the steps that Newton went through when he came up with differential calculus anyways. And the second one is we're learning the difference between a secant and a tangent, which is straightforward. So what is calculus? Two simple geometric problems led to the development of what is now called calculus. Okay, and one of those problems, and the one that we're going to focus on in this course, is what is the slope of the tangent to the curve y equals f of x at a specific point P. So I've drawn a little picture here. There's a point P. What's a tangent? Well, it's a straight line that most resembles the slope of the curve at that specific point. Okay, and it only touches the curve in that one spot. And that's the differential or derivative calculus that we're going to be doing this semester. And then in university, first year, you're going to discuss the second idea, the second problem, fundamental problem of calculus, which is what's the area under the curve y equals f of x from where x equals a to where x equals b. So what would this area be? And that's called integral calculus. So starting off then with an important definition. A tangent is a line that touches a curve at a single point and best resembles the curve at that point. So I took some pictures from what I found on when I Googled tangent. So we can see here we're at a minimum, and we can see that the tangents would be getting smaller and smaller and smaller until horizontal, and then after that they'd be getting larger. So at our minimum point, it does make sense to have a horizontal tangent or a tangent that has a slope of 0. Here we're not quite to the maximum, so our tangent is getting more horizontal, where if we were right at the maximum or the top here, we'd have a horizontal tangent. And then here we've got a pretty steep tangent through that green dot there. Second example here, I've just got showing the tangent line at a specific point on a curve. And then here, this is a good picture because it shows that here, this line is a tangent to this point, but definitely not a tangent to that point on the curve. Okay, so it can cross through the curve at a later time, but the tangent touches the curve in the one spot and best resembles the slope of the curve there. A secant is a line that joins 2 points on a curve. So a tangent just touches in one spot, whereas a secant joins 2 spots on a curve. And that's the difference between a secant and a tangent, outlined pretty straightforwardly in that diagram. So, in grade 10, we learned that the tangent to a point on a circle is always perpendicular to the radius. That's just a property of circles. So, for example, we can use this property to find the slope of the tangent to, that should say, the circle x squared plus y squared equals 25 at the point 4, 3. So I've drawn that circle. We know it's a circle because we have x squared plus y squared equals radius squared. So we know radius squared is 25, which means the radius of our circle is 5, and that's why this point here is 5, 0, 0, 5, negative 5, 0, and 0, negative 5. And then also this point 4, 3 lies on our circle. Okay, all right, so I'm just going to draw in the radius here. Use my calculator for a ruler. So we know that the tangent to the circle at this point is perpendicular to the radius, so it would be good for us to figure out the slope of the radius. And then we can just use some grade 9 math to figure out the slope of the tangent. So the slope of the radius we just look at it as rise over run. It's positive slope. This is our radius here. And so it's up 3 and over 4, so the slope of our radius is 3 over 4. And we know from grade 9 math that if we're perpendicular, so perpendicular, this is a property of circles again, so it's not going to work for everything, just our circle in this case. The slope of the tangent to a circle is perpendicular to the radius at that point. So we know that the slope of the tangent then, we know the slope of perpendicular lines are negative reciprocals, so it should be negative 4 over 3. So starting from this point, if we use our slope of our tangent, and we know this point's on our tangent, we should be able to go, so that's rise over run, down 4, and right 3, down 4 and right 3, which runs off the page, up 4, and left 3. And again, we could draw that in. Oh. My graphing calculator is more straight here. And this would be our tangent right here. And we know that its slope is negative 4 over 3. Okay? And these are perpendicular to each other because we have a circle. So again, tangent touches a curve at only one point. So in this case, the curve is our circle, and best resembles the slope of that curve at that specific point. All right, so now we're going to get into some calculus here. How do we find the slope of a tangent at a specific point if we don't have a geometric property to use? Well, we use calculus. So the following example is going to outline our procedure, Newton's procedure anyways. He came up with it. So our first problem asks us to find the slope of the tangent to the curve f at x equals x squared, which we recognize just as our basic parabola, at the point P24. So here's P right here. And you can see it's over 2 and up 4, so that's P24. So the first problem we encounter is that you need 2 points to get the slope of a line, and right now we only have one, P24. So what we do is we create a point Q that's just a little bit, not right on a corner because we don't want to pretend we know it, just a little bit to the right. So here's P, and then we want to go a little bit to the right to get our point Q. And that point Q is this distance here, this little tiny bit to the right we call H, this distance H. So Q is going to have the coordinates. So let's, first of all, let's write out our coordinates for P. P has the coordinates 2 and 4. To get the coordinates for Q, it's a little more involved. So we know that Q is 2 plus a little bit, and we're calling that little bit H. So we go to the right, 2 plus H. The question is, what would this Y value be? So if our X value is 2 plus H, and our function is f at x equals x squared, how could we find out what our corresponding Y value would be? Well, we can use what we learned about function notation and algebra in grade 11, 10 and 11, to find the Y value. So this expression we put in there is actually going to be our function f at an x value of 2 plus h. And we know, I remember doing this lesson, and a lot of kids are confused on this point. So I might go back and say, well, what would f at 3 be? And most people could say, well, it would be 3 squared, which is 9, okay? Because we replace x with 3. What would f at 4 be? Well, it would be 4 squared, which is 16, okay? What would f at m be? Well, it would be m squared because we replace x with m. So what would f at 2 plus h be if we come back down here? Well, it would be 2 plus h, so I'm replacing x with 2 plus h, but I'm using parentheses because it's not just one number, squared. But I also want to expand that out, so then I have to remember how to multiply binomials together. And we know that we multiply each term in the first bracket by each term in the second bracket. And here we get 4, 2 times 2, plus 2 times h, plus h times 2, plus h times h. And then we can collect those middle terms. So the y value that goes with an x of 2 plus h that is on this curve would have a corresponding y value of 4 plus 4h plus h squared. Okay, so now we have 2 points. Our first point is the point P, 2, 4, and our second point is the point Q with an x value of 2 plus h, so over 2 plus h, and up 4 plus 4h plus h squared. Okay, so now we have 2 points. And if we have 2 points, we could find the slope of the secant. If we join those 2 points together, we could find the line that connects those 2 points, and that would be a secant, which you could draw in if you want to. So PQ, again, is a secant because it joins 2 points on a line. Man, that didn't go through quite nicely, but that's the secant. But what we really want is the slope of the tangent, and that's where Newton's method comes in. All right, so our first problem was we needed 2 points, we only had 1, so we created a second point that was just a little distance to the right away, that h distance away. We found the corresponding y value, so now we have 2 points, P and Q. Okay, so keep that handy. So now that we have 2 points, we can find the slope of the secant through P and Q. Okay, so we can call that either slope of PQ or slope of secant. Okay, either one. And just reminding you again that P was 2 and 4, and Q was 2 plus h, and 4 plus 4h plus h squared. So remember, finding the slope of the line that connects 2 points, we just do y2 minus y1 over x2 minus x1, our slope formula from grade 9. So here's P, that's going to be my x1, y1, and Q, that's going to be my x2, y2. Okay, so then I'm going to substitute in here. MPQ is equal to 4 plus 4h plus h squared. So there's my y2 minus 4 over my x2, which is 2 plus h minus 2. Okay, and we want to simplify this expression as much as we can algebraically. So you can see here I have, if I'm just collecting like terms, I've got 4, but I've also got minus 4. So in the numerator, the slope of my secant, I can add the 4 and minus 4 to get 0. So I have 4h plus h squared. And then similarly in the bottom, I have a 2 and a minus 2, which add up to 0. So I'm just left with h in my denominator. And you might think that's as simple as we can make it, but it's very important that we simplify further than that. So what we can actually do here is common factor out an h in the numerator. So divide 4h by h, and that gives me 4. And divide h squared by h, and that gives me h over h. And now these h's divide out. And we're left with the slope of the secant being just 4 plus h. Okay? So far we found 2 points, and then we found the slope of the line that joins those 2 points together, the slope of the secant. So the slope of our secant is 4 plus h. So we've got the slope of our secant in terms of that little distance h. Okay, so far we haven't done any calculus. We're doing the setup for calculus. So here's where the calculus comes in. So this is Newton's reasoning. Newton figured that the point Q could be put as far or as close to P as you wanted. The closer it is to P, the closer the slope of the secant would resemble or be near the slope of the tangent. In fact, you could move that point Q so it's so close to P that it's virtually indistinguishable from P. So in other words, infinitely close to P, okay? I even said that here, i.e. Q can be moved infinitely close to P. This means that the horizontal distance h is very close to nothing. Okay, so if we look back at this picture here, that little horizontal distance h, we want to minimize as much as possible. We want to have it be like 0.00000000001 so that Q gets so close to P that it's practically indistinguishable from P. Okay, so this is Newton's thinking. He was a genius. Reworded, you could say that as h gets closer and closer to 0, so as that little horizontal distance h gets closer and closer to 0, the point Q closes in on the point P, and the slope of the secant gets closer and closer to the slope of the tangent. And he used the word limit to explain this thinking, or this idea. So he's saying that the slope of the tangent is the limit as that little horizontal distance h approaches 0 of the slope of the secant. So it's the limit. So that's limit is kind of like your regular writing size. And then underneath it's kind of like a subscript size as h, the arrows approaches 0. And we can replace the slope of the secant with 4 plus h. And you can see that as h gets closer and closer and closer to 0, 4 plus almost 0 gets closer and closer to 4. So therefore, the slope of the tangent would be 4. So let's go back to our picture here and just see what does that mean, the slope of the tangent is 4. So I'm going to go back to our picture here, and I'm just going to erase that line that I drew in the secant line. And I'm now going to say, well, we determined through Newton's method for using calculus that the slope of the tangent to this curve at the point P would be 4. So we know P is on our tangent line, and we know the slope of the tangent is 4. So that means if we go over 1 and up 1, 2, 3, 4 to get to another point on our tangent, and then over 1 and up 1, 2, 3, 4 to get to another point on our tangent, because the slope of our tangent is 4 over 1, which is rise over run. And then backwards, we'd go left 1 and down 4, 1, 2, 3, 4. So you can see that if we drew in that tangent line using a ruler, it should look like a line that touches that curve in only one spot at point P, but resembles the slope of the curve at that point, which it does. So that's what we actually found. The slope of the tangent to the curve y equals x squared at the point 2, 4 is 4. Okay, that's what that means. And then there's a really important disclaimer here that Newton made, and that's that h approaches 0, but it can never actually get there. Otherwise, division by 0 would render the solution meaningless. Okay, so, and what are we talking about division by 0? Well, if we come up here to our work on the secant, we had h in our denominator. Okay, so in other words, we're dividing by h here, And it was nice that we could divide them out, but we can only divide them out provided, if you remember grade 11, provided that h is never 0, because you can't ever divide by 0. Okay, remember we did that whole unit on rational expressions and restrictions. So we can't divide by 0, so h can get very close to 0, like 0.000000001, but it can never actually equal 0, or again, that would render the solution meaningless. So that's an important note. It's a way to get around division by 0. Okay, we can approach it, but we can never actually get there. All right, so we're going to kind of go through a bunch of questions now the way Newton did, and before we actually, next video, we'll go to a formula for this. Okay, so, but it's really important that you get the basic underlying foundations of calculus before we move forward. So our next question, find the slope of the tangent to the curve f at x is 4 minus x squared at the point -3, -5. Point P, -3, -5, and I showed it, graphed it for you, did a graph for you. If you aren't able to print it out, do a little sketch here. But, okay, the first step is to set up P and Q. So we've got P given to us. And then Q, we know we want it to be just a little bit to the right. So here's P, Q is going to be just a little bit to the right. So how do we say that? The x is going to be a little bit to the right. Well, it's going to be -3 plus that little bit h. Okay? Then we need the corresponding y value, which takes some effort to get, right? We have to use the defining function to figure it out. So we want to find, so I'm just going to put this down here and do this kind of work under the graph here, if you can see that. So I want to find what is f at -3 plus h. So if I follow this function notation here, that's going to be 4 minus -3 plus h squared. All right, so now I've got to do some algebra. So I'm subtracting this entire square binomial here. And if you can square a binomial in your head, it saves you some time, but I'm going to pretend that maybe you're not at that spot where you can do that yet. So we'll do the FOIL here. So -3 times -3 is 9. -3 times positive h is -3h. H times -3, -3h again. And then positive h times positive h is positive h squared. And then maybe we want to tidy up by collecting these like terms in here. Now though, we're subtracting this whole thing. So we're acting like this is a -1 and then distributing it through here. So I've got 4 minus 9, -1 times -6h, positive 6h minus h squared, which gives me -5 plus 6h minus h squared. So it took me all that algebra just to get the corresponding y value to set up my point Q. So my point Q has an x value of -3 plus h and a y value of -5 plus 6h minus h squared. So step 1 is to get your points P and Q. Step 2 is to find the slope of the secant that joins P and Q. And we know that that's using the grade 9 slope formula. The slope of the line connecting P and Q is y2 minus y1 over x2 minus x1. So P is always going to be my x1, y1, and Q my x2, y2. So y2 is -5 plus 6h minus h squared. And then I'm subtracting y1, which is -5. And then x2 is -3 plus h. And I'm subtracting -3. And then we always want to simplify the slope of the secant as much as possible. So it makes our finding the limit easy. All right, so here I've got a -5 minus -5, so that's really -5 plus 5. So I'm left with 6h minus h squared in the numerator. And then same thing here, I've got -3, and this turns to be +3. So I'm left with h in the bottom. And then again, I can common factor an h out of the top to put this in simplified form. So 6h divided by h is 6, h squared divided by h is h. And now these h's divide out. So I figured out then that the slope of the secant is 6 minus h. Okay. So now we're on to step 3, which is the calculus part. So we haven't really done any calculus up till now. We've just set the question up. So the calculus is the fact that Newton came up with the slope of the tangent is the limit, is that little horizontal distance h approaches 0 of the slope of the secant. So the limit as h approaches 0 of 6 minus h. So imagine h getting really close to 0. 6 minus a number really close to 0 is going to approach 6. So therefore m tangent is equal to 6. Okay, and again, what does that mean? That means that if I was going to draw a tangent line in at point P, it would have a slope of 6 over 1. So over 1 up 1, 2, 3, 4, 5, 6. And we kind of fall off the curve there. But we can draw in our tangent through P and this other point. Oh, that didn't work out so well. Ruler, so that's P. So this would be our tangent right here. And it has a slope of 6. And does that make sense? If we were kind of predicting the slope of the tangent here, if we were just going to draw eyeball one in, we would know it would have a positive slope and fairly steep. So 6 makes sense for the slope of the tangent. Okay, there's our first question. So again, there's 3 kind of parts to the question. First is figuring out P and Q. And usually Q takes some algebra. Then we find the slope of the tangent, so the slope between P and Q, just using the grade 9 slope formula. Then we simplify that as much as possible. In this case, it involved common factoring and reducing. And then step 3 is the calculus, where we say that the slope of the tangent is the limit as h approaches 0 of the slope of the secant. And then we let h approach 0. And we have the slope of our tangent. Then you can always check and make sure that it makes sense. If you have Desmos, for instance, and you were trying a question from the textbook, you could type in y equals 4 minus x squared if it didn't give you a graph. And then we could see the point -3, -5 right down there. And imagine a tangent being drawn in would have a positive, fairly steep slope. Okay, question, next example. Find the slope of the tangent to the curve y equals 2x squared minus 4x plus 3 at the point where x equals -1. Okay, so first of all, in our first step here, it tells us the x value for P, but it doesn't tell us the y value. But it does give us the equation. So if we wanted to know the y value that goes with x, it goes with x being -1, that would have been bad. We would sub -1 into our function here. So replace every x with -1. We can also look at our graph and make sure that it makes sense. So that's going to be +1 times 2 plus 4 plus 3, which is 10. No, 9, sorry. So let's see if -1, 9 is indeed on our graph. There it is. So there's point P. And it's got the coordinates -1, 9. So we actually had to do some work just to get our P this time. And again, so Q is going to be a little bit to the right of it. There's going to be my Q, and we can see that if we were drawing a tangent at P, we would expect it to have a negative slope downward and fairly steep again. So our point Q is going to be a little bit to the right of our point P, so its x value is going to be -1 plus h, and then that y value is what we have to use our function for. So I'm going to come down here, and we're going to find out the y value that goes with x being -1 plus h by replacing every x with -1 plus h. Okay, so that's, so if you can square a binomial in your head, that's great. You'll be able to skip some steps here. Here we would just distribute. Oops. So -4 times -1 is +4. -4 times h is -4h plus 3. Here we have to do FOIL. So -1 times -1 is +1. -1 times h is -h. H times -1, -h again. H times h is h squared. And then I'm already going to look at that +4 plus 3 and make it +7 minus 4h. I've got to distribute the 2 here, so 2 minus 2h minus 2h again, plus 2h squared, plus 7 minus 4h. And then finally, I've got my 2 plus 7 is 9. Minus 2h minus 2h is -4, minus another 4 is -8h, plus 2h squared. So 9 minus 8h plus 2h squared is the corresponding y value. So there's my step 1. I've got my point P and my point Q. Step 2, I want to find the slope between those 2 points using the grade 9 slope formula. So my point P is x1, y1. My point Q is x2, y2. So then that's going to be y2 is 9 minus 8h plus 2h squared minus y1, which is 9, over x2, which is -1 plus h, minus x1, which is -1. So then 9 minus 9 is 0. And -1 minus -1 is 0, because that turns into +1. So then I can common factor h in the numerator so that I can divide out that h in the denominator. So I've got that the slope of the secant is equal to -8 plus 2h. So there's my step 2. Step 3 is the calculus part. So the slope of the tangent is going to be the limit as h approaches 0 of the slope of the secant, which is the limit as h approaches 0 of negative 8 plus 2h. So if h is approaching 0, 2 multiplied by something that's very, very tiny, like 0.000000001, that's going to approach 0 as well. So this term's going to approach 0. So if I take the limit as h approaches 0, it's just going to approach negative 8. So that's going to be my slope of my tangent to the curve at that point. So again, at point P, if we come up to our graph, we're saying the slope of the tangent would be negative 8, which would mean down 8. 1, 2, 3, 4, 5, 6, 7, 8, and right 1. And you can see that that's going to give you a very steep, fairly steep tangent, okay, and a negative, which is what we expected to get when we first looked at our question. Okay, next example. Find the slope of the tangent to the curve y equals 4 over x plus 1 at the point where x equals negative 3. Okay, so this is a different, not a parabola anymore. This is a hyperbola, if you remember grade 11, or advanced functions. It says at the point where x equals negative 3, so the first step is we want our points P, and again, we're just given the x value this time. And we can find the y value by substituting in negative 3 for x. My y value is going to be negative 2, it should be. Now let's look on our graph. Negative 1, 2, 3, negative 2 is a point. There's our point P. And it is a point on our graph. Q then is going to be just a little bit to the right. Okay, so it's going to be at a x value of negative 3 plus that little bit h. And then again, we'll do a little bit of work over here to get our y value. So our y value is going to be 4 over our x is negative 3 plus h plus 1. And we can combine those to get 4 over negative 2 plus h. So here's our x1, y1, point P, and our x2, y2 for Q. Okay, so now we want to get the slope of the secant between those 2 points. And we also want to simplify it using algebra. So y2 is 4 over negative 2 plus h minus y1, which is negative 2. x2 is negative 3 plus h minus negative 3. Okay, so here we're really adding because we're subtracting negative 2, so we can think of it as adding. So we have a fraction and a whole number, and the way you have to add those is to get a common denominator. So right now your denominators that you're looking at are negative 2 plus h and 1 within the numerator. So the common denominator is going to be negative 2 plus h. So we're just dealing with the numerator right now. Okay. So this fraction already had that denominator, negative 2 plus h, so its numerator will stay 4. This denominator was 1, and we had to multiply by negative 2 plus h. So we also have to multiply the top by negative 2 plus h. Whatever you did to the bottom, multiply by negative 2 plus h, you have to do to the top as well. Over, so here in the denominator, we have negative 3 plus h, and then again minus negative 3, so these negative 3 minus negative 3 adds up to 0, and we're just left with this h in the denominator. So we're going to continue to simplify here. So now that we have a common denominator, we can add the numerators over the common denominator, and then that's all over h. Remember, this h is approaching 0, so we don't want to end up with it because it can't actually, we can't ever have our denominator be 0. Okay, so within the numerator here, I'm going to distribute. So 4 plus 2 times negative 2 is minus 4 plus 2h over negative 2 plus h. Now this is a big divided by sign, so we're dividing this fraction by this fraction if you think of it as being out of 1. So we know that to divide by a fraction is to multiply by the reciprocal. So dividing by h over 1 is the same as multiplying by 1 over h. Okay, so that's where that comes from. So we've taken care of everything here. I'm going to simplify the numerator here a bit more. So I've got 4 minus 4 is 0, so I've just left with 2h in the top of this first fraction, and negative 2 plus h times 1 over h. So then multiplying top by top, bottom by bottom, but rather than multiply this distributing, I'm just going to put my monomial term, this plain h, out front and show that it's being multiplied by the negative 2 plus h. And in that way, I can divide out this h and this h. So the slope of my secant turns out to be, and simplified as much as I can, 2 over negative 2 plus h. So there's the slope of my secant. And then kind of running out of room here, so we'll do step 3 over here. So that's where I find the slope of the tangent by taking the limit as h approaches 0 of the slope of the secant, or the limit as h approaches 0 of 2 over negative 2 plus h. So if we let h approach 0, the denominator is just going to approach negative 2. And 2 divided by negative 2 is negative 1. So the slope of our tangent is negative 1. And again, we can see that that makes sense if we go back up to our diagram. So here's point P. We're saying that a tangent at point P would have a slope of negative 1, which means down 1 over 1, down 1 over 1. Reverse it, and you can see if you were going to draw a line through those points, it would look like a tangent to point P at the curve. On the curve. Okay. So we've done parabolas, we did a hyperbola, and the last one we're going to do today is a square root function, starting at this point. So find the slope of the tangent to the curve f at x equals the square root of x plus 3 at the point 1, 2. So our first step, they give us our first point, 1, 2. Let's figure out where that is, right here. There's our point P. And we'll choose a Q a little bit to the right of it. So the x value is going to be 1 plus h, whatever my x value is, plus that little horizontal distance h. This is Q. And then again, we have to use function notation to figure out what our corresponding y value is going to be. So f at 1 plus h is going to be the square root of 1 plus h plus 3, which is the square root of 4 plus h. And that's the best you can do. So we're going to have a square root here. So there's our step 1. We've got our point P, x1, y1, and our point Q, x2, y2. So step 2, We want to find the slope of the secant, or the slope between points P and Q. And if you look at it, we're expecting a positive, fairly low, or fairly non-steep slope. Okay, if we were looking at drawing in a tangent there. And we just use our grade 9 slope formula to find the slope of the secant first. So y2 is the square root of 4 plus h. And then we've got our minus sign. And then 2 over x2, which is 1 plus h, minus x1, which is 1. And we've got the square root of 4 plus h minus 2, and in the denominator we just have h. So if we thought that this was as simplified as we could get, we'd have a problem, because we can't let h approach 0, because then the denominator approaches 0 and we can't divide by 0. So there's got to be a way to divide out this, I call it the problematic h. Okay, we have to be able to divide this out somehow. And we haven't done this before, so this is a new technique. This is called multiplying by the conjugate radical. So what we're going to do is multiply by 1 in a way that's going to allow us to free up this h here. Okay, so we're going to multiply by the conjugate of this numerator here. So the conjugate of this is going to have the exact same thing under the square root. So 4, it's going to be the square root of 4 plus h, and instead of minus 2, it's going to be plus 2. Okay? But if we do that to the top, we have to do it to the bottom, so that we've really just multiplied by 1 in a strategic way. That's going to allow us to free that h there, and we'll see how in a second. So we're going to look at the top here. So here's a bracket and here's a bracket, and we're going to do some FOIL in our numerator. Okay? Okay, so we're multiplying the square root of 4 plus h by itself. The square root of 4 plus h by the square root of 4 plus h. So if you multiply a square root by itself, you're squaring it, or you're undoing the square root. So by multiplying, so we're thinking root of 4 plus h, doing that off to the side here, times itself is going to give you the square root of 4 plus h squared, which is just 4 plus h. Okay, so that's the thinking there. So that's first by first, or the first green arrow here. Now we're going to do this second green arrow. So that's the square root of 4 plus h times positive 2. So that's going to be positive 2 root of 4 plus h. Now we're going to do this bottom first green arrow here. So that's negative 2 times the square root of 4 plus h. So negative 2 root of 4 plus h. And then finally, we're going to do this last green arrow here. Negative 2 times positive 2 is negative 4. And then in the bottom, we're just going to keep it as our h that we want to be able to divide out, our problematic h, and then times this root of 4 plus h plus 2. Okay? Just keep it like that. Now, if you see here, we've got plus 2 root 4 plus h minus 2 root 4 plus h. And those add up to 0, which leaves my numerator as 4 plus h minus 4, because those just add up to 0. And that's by multiplying by the conjugate radical, we call it. We set it up for that to happen. Okay, so that h is, you're going to see in a second, is going to become free to divide out with the problematic h that we don't want to allow to be 0. Okay, so then you can see what happens here. I've got 4 and minus 4, so I've got my slope of my secant. Those add to 0. And finally, after all that algebra, I can divide those h's out. But remember that there's really a 1 left on top there. So all that work led me to knowing that the slope of the secant, or the line joining the points P and Q, is 1 over the square root of 4 plus h plus 2. And then the step 3 is where I find the slope of the tangent. And it's going to be the limit as h approaches 0 of the slope of the secant, which is 1 over the square root of 4 plus h plus 2. So if we let h approach 0, then the numerator is going to stay the same, 1. The denominator, this part, if h approaches 0, this part's going to approach the square root of 4. But we still have this plus 2 that's unaffected by h. Square root of 4 is 2. So we finally end up with, oops, sorry guys, went off the page there, to see that, therefore, the slope of the tangent is 1/4. Okay, so if we look up at our picture again, so we got the slope of the tangent to be 1/4. We said it would be positive. We said it would be not very steep, and 1/4 means up 1 and over 4. 1, 2, 3, 4. Down 1, 1, 2, 3, 4. So you can see that the tangent would be not very steep and positive. So our slope of our tangent way down here makes sense. Okay, so that was a new technique we used here, which was multiplying by the conjugate radical. So it's going to have everything the same except the sign in the middle, okay? And that sets up you to be able to cancel out the middle terms, or the middle terms are going to add up to 0, as long as you know how to find that conjugate radical. Okay, so our success criteria for this first intro to calculus lesson is that we can find the slope of the tangent to a curve at a specific point using the underlying ideas behind calculus. We understand what's meant by the statement that the slope of the tangent is equal to the limit as h approaches 0 of the slope of the secant. We understand that h can get infinitely close to 0, but it can never actually equal 0. Okay, and we understand that division by 0 is not defined. All right, so that is our first intro to calculus lesson. This is how Newton first came up with calculus. He always used these 3 steps. And we continue on later this week. We will refine this to what we call a slope of the tangent formula. Okay.